Hi. Today I'm pleased to talk about gallium-68 and copper-64 labeling and affinity study of NODAGANOC, a NODAGA conjugated somatostatin analogue. As you know, somatostatin receptors were normally expressed in healthy cells and overexpressed in neuroendocrine tumor cells. These receptors are also ideal ligand to develop for drug development. The natural ligand is somatostatin. If labeled with suitable radioisotopes, the uptake with neuroendocrine tumor cell increases the target to background ratio. This is true in vitro, but it isn't the case in vivo because the very rapid in vivo degradation with peptidase of the natural somatostatin. That's why somatostatin, more stable somatostatin analogues were developed. The first one was octreotide, which was largely used to inspect application after its conjugation with DTPA chelator and its labeling with indium 111. The modification, the 1 to 2 amino acids residues in octreotide leads to the most used somatostatin analogues in PET imaging, DOTATOC, DOTATATE, and DOTANOC. The data analysis of IC50 of the DOTA conjugated peptides shows that the replacement of the phenylalanine in the octreotide by the tyrosine decreases affinity for subtypes SST3 and SST5 somatostatin receptors. Contrary to that, the replacement of the same phenylalanine in the position 3 by more lipophilic residue, amino acid residue, naphthylalanine in the position 3 leads to increase of the IC50, the affinity for 3 subtypes, SST2, 3, and 5. The advantage of peptides with broad profile, affinity profile is to increase the targeted tumors which express several subtypes of somatostatin. That's why we are particularly interested to these NOC peptides. But why NODAGA? Look at two parameters used to evaluate the affinity, the stability of the complex of metal with chelator. The constant of stability constant, KML, the logarithm of KML, and which can be used to evaluate the in vitro stability, but do not predict the in vivo stability. That's why we used PM value, which is a negative logarithm of metal, free metal unchelated with chelator under specific conditions. This parameter gives us more relevant biological stability information than the constant of stability. But if this figure to be useful as radiopharmaceutical gallium compound have to be thermodynamically stable. The second requirement is that in vivo it undergoes no exchange with abundant protein plasma transferrin, which has two sites, iron binding sites with high affinity to gallium-3+. As shown in this figure, the complex of gallium with NOTA is more stable than the complex with DOTA. But when NOTA is conjugated to a ligand, the gallium complex, the formed gallium complex is only pentacoordinated, thus unstable. That's why it's better to use a derivative from NOTA, which enables the formation of hexacoordinated complex with gallium, thus more stable in vivo. That's why we have a particular interest, we are particularly interested to NODAGA conjugated NOC peptide. what about the affinity of NODAGANOC to the somatostatin receptors? In our work, we evaluated this affinity in vivo AR42J rat pancreatic cell line, which express mRNA of somatostatin receptor subtypes 1, 2, 3, and 5. The IC50 was determined from competitive experiments between variable concentration of NODAGANOC, called NODAGANOC, and fixed concentration, nanomolar concentration of gallium-68 labeled DOTANOC, and the analysis of competition curve with GraphPad Prism software leads to the determination of IC50 of the NODAGANOC. It is 1.2 plus or minus 0.5 nanomolar. Our results are not directly comparable to the results issued from experiments using isolated receptors, but given the total living cells reflects better the reality, we can say that the nanomolar affinity of the NODAGANOC for somatostatin receptor makes this peptide interesting to target somatostatin receptors in cells overexpressing these receptors. The second part of work is the labeling with two positron emission isotopes, gallium-68 and copper-64. For gallium-68 labeling, we mixed 35 nanomole of NODAGANOC with more than 90% of the available activity in generator obtained by fractional elution, and 800 microliters of 1 molar acetate, ammonium acetate buffer. The labeling occurs instantly, and the gallium-68 NODAGANOC obtained with radiochemical purity more than 95% in all cases. Stability check 2 hours later in room temperature and after incubation in plasma at human plasma at 37 degrees Celsius shows that RCP remain greater than 90% in all cases. For copper-64 labeling, the labeling was performed according to Oxford and collaborator method. 10 nanomole of the peptide were mixed with copper chloride 50 microliter containing about 60 megabecquerel of activity, and 250 microliter of 0.1 molar ammonium acetate buffer. After incubation at room temperature during 15 minutes, we obtained copper-64 NODAGANOC with RCP equal to 100%. The stability, this RCP remained unchanged after 20 hours incubation in human plasma at 37 degrees Celsius. In view of these results, we can say that the nanomolar affinity for living cells, AR42J, makes NODAGANOC a potential interesting vector for targeting of pathologies overexpressing the somatostatin receptor. The used labeling methods were performed without costly equipment and leads to gallium-68 and copper-64 NODAGANOC with high RCP without further purification and with good stability. Recently, preliminary results of gallium-68 labeling with a method which was described in the last INM using sodium acetate buffer gives better results with RCP equal to 100%. After this work, next steps are we have to do in vivo studies and imaging. And thank you for your attention.
Thank you very much indeed. This paper is now open for questions. Everybody's coffee needs to kick in. I think a few of us a little jet lagged. No? Okay, well, if you're going to be available at the end, if anybody has any questions, then we can find the speakers in. Thank you very much indeed. Thank you.
So.